Good morning, students. Today we will see helical gears, physics of helical gears. Already we have seen spur gear, its design. Helical gear is also similar to spur gear, but you will find teeth are cut with some inclination with the axis of rotation. This axis of this inclination is known as helix angle. In helical gear, the contact between the missing teeth gradually extends along the diagonal line across the tooth. And there is a gradual pickup of load by a tooth. Therefore, it results in smooth engagement and smooth operation even at high speed. Even at high speed. Look at this figure. You will find here the teeth are cut with some inclination. That inclination is the helix angle. This is the axis of the tooth. This is the helix. And because of that, the gradual engagement is possible in case of helical gear. Because of that, it transfers the load from one tooth to the another tooth. And because of this, it also transmits heavy loads at high speeds. So you will find the helical gears in atomoil gearboxes, then turbines, then high-speed applications, even up to 300 per minute. Now let us see. This is about the helix angle, and because of that, how it is going to engage with the meshing gear. Then in terminology part, the conventional representation, how to represent it on a paper. You will find here, this is a pinion, this gear is a gear or helical gear. How to represent it here? It's here, this is the axis. This is also the axis of the gear, axis of the pinion. Here it is going to mesh. But here, how to represent it on a paper here? Helix are shown here. Look at this. Now in this case, in one pair, one gear is having right hand helical teeth, another gear is having left hand helical teeth. Now look at this. How to decide this? Right hand and the left hand teeth. One gear is right hand, another one is the left hand. Then and then it is going to properly mesh, or there is a gradual engagement. Again, here you will find in this case the lines are sloping. Look at this. For right handed, lines are sloping towards right hand, towards the right hand lines. So you can say it's a right hand helical teeth. And in this case, in left hand, the lines are sloping towards the left hand. You can say it's a left hand helical teeth, and they are going to mix. That means to have a proper mixing between them, here one gear must have a right hand and helical teeth, and another gear must have a left hand. Then and then it's possible, other engagement is possible. And it's the represented on a paper. It's a representation, conventional representation of helical. Now let us see the another important point, that is virtual number of teeth. What do you mean by virtual number of teeth? We have seen here in helical gears, spur gears, teeth are cut which are parallel to the axis of the shaft. But in helical gear, teeth are cut with some inclination, that is helix angle, and that range may be in the 15 degree to up to 25 degree. We have already discussed the physical significance of helix angle on the performance of the helical gear also. Later on, we will further discuss these things. But before that, let us see what you mean by virtual number of teeth. Now we are, very well. Look at this here. This is the gear. Here it is helical gear, helix which is shown, or teeth which is cut with an helix. Psi is the helix angle here. Psi is a helical gear. B is the base width, it's a pitch cylinder, D is the diameter of the gear. All nomenclatures are given here. If this pitch cylinder of a helical gear, if it's cut by this plane AA, look at this. This is the plane AA. This is the this plane AA. If it's cut by this plane AA, okay, this plane AA. So you will find this plane which is again normal here, normal to the tooth element. When cylinder, this cylinder is cut by plane which is inclined, so what would happen? You will find the cut section. Look at this here. This cut section is an ellipse, and if we apply the rule of engineering drawing, so you will find intersection of the plane A, which is inclined to the base cylinder, and the piece cylinder extended. If it is extended, look at this here, extended, so you will find it produces an ellipse. It produces an ellipse, and this ellipse is shown by dash dash line. This ellipse is shown by dash dash line. But what is the major and minor axis of this ellipse? The semi-major axis here, it is given here. Look at this. This is the minor axis. This is the major axis. The semi means half of that. The year, this is semi-major axis d by 2. How to find out again here? So you know very well, this is d. This angle is helix angle psi. And if you are going to take here the half of this here, the helix angle is the psi, you will find d by 2 cos psi. This distance. This distance how much? D by 2 cos psi. Semi-major axis. Then what's about the semi-minor? The semi-minor is d by 2 here. Total is the d by 2 is the this. Therefore, here I have written, if the plane A and the P cylinder produces an ellipse is extended, the semi-major axis is d upon 2 cos psi, and semi-minor axis is d by 2. Then, very important, analytically it can be proved here. Look at this. Here this gear is drawn, that radius of curvature, look at this here, O and O dash, O dash. Here radius of curvature R dash, this radius R dash at point B, that means for this, is given up to this, you know, the O dash to up to this, for radius of curvature. If you are going to construct, so you will get here a one formative gear, that is per gear, or you can say formative gear simply. The R dash at point P, that we have to find out. And this R dash here, the radius of curvature at the point B is given A square by B, where A and B are the semi-major and semi-minor axis respectively. But we know A is equal to D upon 2 cos psi, and B is equal to B by 2. The radius of curvature that we have to find out to construct this formative gear. So after substituting the value of A and B in this equation, so what would we get? R dash is equal to D upon 2 cos square psi. But D means 2R dash, or D dash is equal to D upon cos square. So you will get this. The pitch circle diameter of this virtual or formative gear is D upon cos square psi. So what do you mean by this virtual gear? It's an imaginary spur gear. It's considered in the plane A with center O dash. So what we have to do, taking this R dash is the radius, we have to construct the gear. The year it is shown in this another figure. Look at this. R dash is the radius, and the gear is constructed. This gear is known as formative gear, having R dash is equal to D by 2 into cos square psi. O dash is the center. Okay. And it's this gear or is called as formative or virtual spur gear. Virtual spur gear. The number of teeth, that is Z dash, on this imaginary spur gear is called virtual number of teeth. That means to make analysis simple one of helical gear. So we have to convert this helical gear into imaginary spur gear. It will help us to make analysis simple one, and that's why. So what we have to do, we have to find out this number of teeth Z dash, or it is also known as virtual number of teeth. Let us see how to find out. So we know very well Z dash is equal to 2 pi r dash by Pn. Again here r dash radius t by 2 cos square psi. You can substitute the value of r dash here, and Pn is equal to normal, which is equal to pi m n. Mn is the normal model. You know very well all nomenclature. Therefore, Z dash is equal to d upon mn cos square psi. Again, we know that this circle diameter d of the helical gear, which is given d is equal to z into m or mz. Again, here m is equal to mn upon cos psi. M is the transverse module, mn is the normal module. So m transverse is equal to mn cos psi. You can substitute here. You will get z mn upon cos psi. Then therefore, what you will get, d is equal to z mn upon cos psi. So we have to substitute this value of d here. So you will get z mn upon mn cos square psi. You can cancel mn mn. Then what is the remaining? Z dash is equal to z upon cos cube psi. This is the virtual number of teeth Z dash. And Z means actual number of teeth on here. Try to understand. This is about the virtual number of teeth. This is about the virtual number of teeth. In helical gear, to make its analysis simple, we have to find out imaginary spur gear to make analysis simple, and that's why we have to find out number of teeth Z dash or virtual number of teeth on helical gear. Now another important point, that is minimum face width in tooth proportions. Suppose you know how much is the addendum of helical here, you know very well that is equal to MA normal model, then addendum is equal to 1.25 times the normal model, clearance is equal to 0.25 times the normal model, then pitch circle diameter of the helical here, ZMN upon cos psi. In this way, one important parameter, that is minimum face width required in case of helical gear. Look at this diagram. This diagram or a figure, it represents, you will find the top view of a helical gear. If you are going to observe from a top view, it's a top view of a helical gear. Again here you will observe here. Yeah, look at this. The direction of motion which is shown by arrow. Suppose this is the axis here. It is going to rotate direction which is shown in this way. That means arrow represents the gear rotates from left to right, left to right. And for this rotation, point A1, look at this, point A1, it will be the first point coming in contact with the meshing gear. And point A2 is the last point which is coming at the end, or last point to come in contact with the meshing tooth of the gear. The A1 is the starting point, A2 is the last point. But here, as per the the in theory of machine you already studied, A1 is the starting point, or it's the first point which come in contact with the meshing tooth on other gear, and this point or edge is known as leading edge. A1 is known as leading edge. Then this point is A2. This A2 will be the last point coming in contact with the meshing tooth of the other gear, and this is known as trailing edge. Try to understand. A1 is the leading edge point, and A2 is the drilling. Already you studied in theory of machine. Okay. Then, in order to have a contact on the face of the tooth here, so always here I have written here, the leading edge should be advanced ahead of the trailing edge by a distance greater than circular pitch. That means leading edge should be advanced. Leading means this. If A1 top to end or trailing edge here, and when another teeth comes in contact with the meshing gear, that time here, this leading edge should be advanced side of trailing by a distance greater than circular pitch. That means here, you know that this is the teeth which is inclined by helix angle psi, and based on that, what we have to do, considering this, the leading edge should be advanced side of trailing edge. So we have to consider, and it should be greater than circular pitch. That means this distance, look at this, A1 is the leading point, A2 is the trailing, and if I am going to look at another point, it's C. That means when this point comes in contact with another teeth of the another meshing pair, that time this distance is X, or you can say this advanced side of trailing by distance greater than pitch, or X should be greater than P. Simply, X should be greater than P. And that's why I am going to write X should be greater or equal to P. Further, if we are going to take into account this triangle, A1, A2, C, it's a right angle triangle. Look at this here. And this angle made by this, the teeth with the axis of the helical gear is psi. Then what would we get here? Tan psi is equal to A2C upon A1C. A2C means, look at this, it's a X. And the A1C means B here. It's written here B. Then you can substitute X upon B. The tan psi is equal to X by B. To find out X here, so what you will get? X is equal to B tan psi. Then you can substitute this value here. So what you will get here? X means B tan psi greater or equal to P. Here it is written. Therefore, B is equal or greater than. You can send this side towards this side. The P upon tan psi. But here I am writing once again. P upon tan psi is equal to, you know very well, P is equal to pi mn. M is the transfer module here. Is equal to, again, you can replace M in helical gear by Mn upon cos psi. I am going to substitute this value, pi into Mn upon tan psi into cos psi. Now here, okay. Then you can write here, tan psi means, again, sin psi upon cos psi. Cos psi gets cancelled, and what you will get here? Pi mn, it's not digit, pi mn upon sin psi. It's a, I am going to write again here, this point here. This should be pi, try to understand. This should be pi, it's not a z. By mistake, it's written pi m, pi into mn upon sin psi. Okay, then you will, I have written the b is greater or equal to pi mn upon sin psi. It's a mistake in book. I have taken directly. Get this. If possible, I will change it here. This z that we have to replace here by pi. Okay, it's okay, no problem. Here, these points. It's okay, no problem. And this is b. Or you can say it's a minimum phase width which is required, that b should be greater or equal to pi m upon psi, sin psi. Thank you. I have referred V.V. Bhandari's book. If you have any query, V.V. Bhandari's book on microoil publication, third edition. If you have any query, please contact me at 9890426679 or mail me at pvkushare@kkorg.edu.in. Reference book I have referred for this analysis is V.V. Bhandari's book, Design of Machine Element. Thank you very much. The concluding remark, in this session we have seen what do you mean by helical gear, then helix angle, its importance, and what are the advantages of helical gear with spur gear, and here how the helix angle plays important role for gradual engagement, smooth transfer of load, and to transmit the heavy loads at high speed. Then the representation, conventional representation of helical gear, and how right hand and left hand tips are going to engage gradually. Then one gear should have a right hand and other gear should have a left hand tip. What do you mean by right hand? The slope line towards going down towards the right and slope line going towards the left. You can say the left hand helical tip. How to represent it? That means by constructing this line or slope lines, it will decide whether a left or a whether a right on a paper. Then virtual number of teeth. Why virtual number of teeth plays important role? Because by doing this analysis, we are constructing the formative gear. It is imaginary spur gear, which is equivalent to helical gear. Need to help us to make the analysis of helical gear simple one. That's why virtual number of teeth plays important role here, and how to construct it, how to take these cuts. If the P cylinder is cut by plane, then if it extends, produces an ellipse, then what is the semi-major axis and the minor axis of the ellipse, then how to find out radius of curvature, then by using that radius of curvature, how to construct imaginary spur gear. This imaginary spur gear is called a formative or a virtual spur gear, and number of teeth on that formative gear is known as formative teeth. How to find out this? We have seen z dash is equal to z upon cos cube psi, where z is the actual number of teeth on gear. Then we have seen minimum phase width for a proper engagement of the gear, helical gears. Then how to find out this minimum phase width, how to consider the top view, then the leading edge, trailing edge, then advancement of distance for the engagement of the helical pinion with the helical gear. That time leading edge should be advanced side of the trailing edge by distance greater than circular pitch. And then to have a proper contact, the contact should be greater than one or minimum one pair should be in contact, very well in form. And then based on this fundamental, we have derived this expression B should be greater than pi mn upon sin psi. This is about the today's session. Thank you. Thank you very much.